welcome. Glad you're all here today. I want to start with a short raise of hands. Who was here yesterday? Good. And who was at the Ignite yesterday? A little bit less? Okay. We'll come back to that later in the presentation somewhere. But good to know. So first off, I want to start with who am I, why am I talking about this subject, why did I pick this picture. My background is not in IT at all. I studied international business and languages and then thought, what is fun about that actually? Let's go into intercultural communication. Human behavior, why do people do what they do, and learn some languages along the way. That is quite a big jump to DevOps and IT in general. So I think it's interesting to know how I got there. When I started working, I was thinking, okay, nice, let's help people use systems from a fully functional perspective. And once I started doing that, I started asking a little bit too many curious questions. How is this system made? What do you actually do in the background? Why is this doing this, but if I do a workaround, it does that? The answer was, doesn't matter, that's not your job. Which was not the best answer for me, because I wanted to know. So I did some evening projects to see if I would even like the IT world, because as you got from my background, nothing about that was IT. And in my mind, IT equaled math. And math was not my greatest subject. But I did some Python in the evening hours. I was like, this is not math, it's just logic. And I can work with logic. Someone recommended me to read a book about DevOps Phoenix projects specifically. And for someone who didn't have an IT background, that was the gateway into IT. Wait, I know this, it's human behavior, but then in IT, it's processes, it's flows. I think I can do this. I jumped into a traineeship, and I do have to say jumped in, because I had to learn from scratch what is Linux and the command line in Git. And at the end, I had to deploy VMs with infrastructure as code, deploy an application, test the application, destroy the whole environment, monitor the behavior of the application, and present it to senior consultants. Quite big jump, but I loved the whole way. Every step was so interesting that I was really happy that I made that jump. Then I started working at clients. So as a consultant, just join a team, see if you can help them make their work better. And the recurrent team there was platform engineering. This went from startups who had some clusters clicked together. How can we automate that? To big organizations who already had very complex systems set up. How can we improve those? So all things were platform. And that triggered me because I read the book, The Phoenix Project, and DevOps is a big subject there. But what is platform engineering in that sense? And how do they relate and help each other? I split up the presentation in two parts. The first part, boring part, theoretical part. But I do think it's important we start from a good spot together, that we have these same definitions. If we're talking about the boring part, let's make a boring slide. So let's get the concepts right. We have platform engineering. There's many definitions, and a lot of them are insanely long. So I was putting things together, hoping to make a shorter version of it. And I went with tools and technology glued together and maintained by a platform engineering team. Is that all-encompassing? No, but it's almost impossible to do that in a definition. In my opinion, the second one, to what end, is the more important part. So, to what end do we do platform engineering? To enable developers to spend time and energy on their core business, developing. Another buzzword, enabling. What is enabling? I went with ensuring that teams that add value have all the stepping stones to do so, enabling them to bring the most value. I think this to then makes more sense, but to improve developer outcomes, including productivity. If you look well, you see a sentence form with all the green words, which is a team enabling the developer. That's the core of what I think platform engineering is. I'm introducing a theme here, which is Harry Potter, one of my favorite books. And I'm introducing it on purpose here because a lot of the theory is a little bit fantasy worlds and magic and actually not working in real life. But we're still in the theory part of the presentation, so let's pretend we're in Harry Potter and the role of the platform team. So in an ideal situation, where would the platform team and the DevOps team map? So we have this stream-aligned team, which in this case is the DevOps team. They have a flow and a stream of bringing business value. You have the enabling team, which helps the streamlined team to overcome their obstacles. These are the team topologies, by the way, interesting page if you want more on all these concepts. Then we have the complicated subsystem teams, the very specified knowledge. And we have the platform team, so providing an internal product to accelerate the delivery of stream-aligned teams. Very theoretical. I don't think most organizations implement it this way, but again, theory. The enabling team can be somewhere in the platform team sometimes, or not there at all. Everyone has their own silo. Let's talk about tools now and actual IT. Developer experience platform architecture. I do have to start with the disclaimer. This is opinionated, obviously, and there's a multitude of tools for each and every part of this slide, but you need something fun. So we have the application team with their applications, which can be also a multitude of things, but web front ends, web services, data processing workloads, machine learning workloads, the newest of course, but there's many more. But that is the application in the platform architecture. Then we have the platform interfaces, so what you interact with as a developer. That can be developer portals, like Backstage. It can also just be APIs, or golden paths, templates, good old documentation, and everyone is building an AI assistant, I think, so we have to include there as well. Below the interface, so you interact with the interface level, but below that there are also an endless list, but try to keep it concise, platform capabilities. We have identity and access. We have source code artifacts, pipelines and reconcilers. Reconcilers specifically to also include Argo CD, one of my favorites. We have observability, of course, you need to know what's happening. Generative AI. The multi-tenant orchestration, in whichever way form we want to use that. Service mesh gateways, policy and scanning, secret management, machine learning, and then the bottom layer is, I would say, the old school main components of a platform: compute, networking, storage, messaging, and databases. We can have a discussion on if this is all within one platform team. I think that depends on the organization and the skill set that is there. They could be multiple teams or just all in one. And then back to the real subject of the talk. How does platform engineering give power back to developers? And how can we make sure that the platform engineering job doesn't sound too boring? This slide doesn't do that because it shows that developers' jobs are actually very fun. Agility, collaboration, flexibility, productivity, all the fun subjects. And platform engineers make sure you're secure, boring. Governance, boring. Standardization, sounds like a Ford's car company. Cost management, no one wants to talk about cost management. All the boring parts. It's not boring in real life, but on this slide it's boring. Now let's go to the value. I'm introducing a new theme here next to Harry Potter, which will come back as well. But I currently work for Schiphol Airport as a lead engineer of the container platform team there. So my context is usually airports. So I try to include some examples of airports in this presentation because I think most people have been to an airport before. What is the first value that platform engineering brings to DevOps teams? It requires some context, which is the top layer. In the traditional approach with DevOps, everything has been shift left. Give it all to the developers, they can do it fast, they can do it themselves, they can manage the whole thing and deliver faster value. But with the growing load of all the tools and capabilities you need to know as a DevOps team, there's just an overload. The cognitive load is too high and you actually lose a lot of time figuring out what is the best tool for what you need to do. How does platform engineering solve that, or what value does it bring? The first one for me is self-service. So yes, do it yourself, but you don't need to have all the expert knowledge on the subject. I want to get something done, click it, get feedback. Hey, it works. I don't need to know what's all behind it, but I did get the end result I wanted. It's reduced cognitive load, because you don't need to know everything about all the subjects. And why Voldemort is here, it's automation, but it feels automagical. You click something, you get the result. You don't need to know what magic is behind it. An example with the airport, because everyone has been there before, I think. I'm not sure if all airports do this, but a lot of airports have the self-check-in of luggage. The systems where you can just put in your bag, check in, and off you go. The system is not different per airline. You just click it. It says, yeah, you want to check in. This is your limit, put your bag on the band. You're within your means. There you go. You don't need to know what's happening behind it to make sure it ends up at your plane. You just want to get rid of your luggage and not carry it around the whole airport anymore. If you make that into a real IT example, I think the favorite thing to request from everyone is firewall rules. Right? That's always great. You have a ticketing system, you put in your values, it ends up in a black box somewhere. You get feedback, maybe, or a no, without any real answer why. If you were to make that self-service, you would have some guardrails, you fill in your values, and you get instant feedback, yes, this is allowed, or it's not allowed, or it's being implemented as we speak. You can do that with other things as well, right? Namespaces, quotas, container platform specific things, but firewalls are, I think, an example that works for a lot of situations. Then we have the second value, standardization. Standardization looks complex. It's not that complex as this image. But what does standardization do? By reducing the options, you also reduce the cognitive load. If there's one pipeline tool to use within the organization, you don't even need to make that choice. You make it work, and you end up with something to deploy your applications. You get security and governance by default. The boring subjects we talked about, you already get those. You don't need to think about what exact security and governance do I need to apply. You get a default set. And shift down, and shift down I will explain in the following slide. So shift down lives next to shift left. We talked about shift left already. It's focused on autonomy, give the power back to developers. But we also have shift down, and I'm going to talk from the bottom up. So shift down is the focus on standardization to make shift left less complex. So we have the opinionated defaults. The opinionated defaults are the best practices, starting configuration, templates if you will. How can you start with something and know it's probably going to work? Then we have the platform abstractions, which are the representations or interfaces which you interact with. Hey, it's easy to use this platform because I have this visual representation, interact with, it works. And then on top of that, we have the golden path. It's a path of least resistance. If you go through this flow, all will be fine. And then the other parts, of course, work into the golden path. If we were to take that back to the luggage example, you put your luggage into the system, it ends up in a beautiful factory of complex systems, which brings your luggage to your airplane. It's no different per airline. It just ends up here in this big system. What if all the airlines said, but I want to make my own? You know what? I can do this myself. I have some cool things. I'll introduce them. It sounds weird, but in IT, we do it. There's multiple teams that says, you know what? I can spin up a cluster. Maybe OpenShift or vanilla Kubernetes or Rancher, whatever. I can spin it up. I can configure it myself, and I'm faster and I can deploy. What you forget in that image is that you need to have the security practices applied, you need to have the guardrails and governance, you need to have an upgrade process, which also makes sure that all your components keep working. You lose a lot of developing time if you also need to manage this. If you can just land on someone else's work, it gives you more time to do your own work. And the third value, I looked up Robert Boyce, he's an economics guy, but I think it works in IT as well. So knowledge is power, but knowledge shared is power multiplied. This goes for platform engineering as well. So you have a couple of flows where knowledge can come from. You have the platform team itself, who are experts on the subject of platforms, and where you can ask your questions and verify your use cases. If I were to do this, would this work? You have some sparring partner. Then you also have knowledge from new teams or low maturity teams who do something on a platform for the first time ever. Because they challenge you on your assumptions. What is logical for a platform engineer may not always be logical for a new DevOps engineer. So they help you make that golden path as easy as possible. And then you have the mature teams, the usually quite critical ones. Wait, you're missing this and this and this in your platform and it's not workable for me. If you translate that a bit, they just want you to be better. So take that feedback as it is. Let's see if we can make the platform better. So the knowledge from the platform team then takes all in the feedback from all the other teams and gives it back to all the other teams. So it's a constant flow, constant feedback loop, which makes the knowledge shared power multiplied. I tried to find an airport example for this. I also asked AI, first of all, what is this image? I used it anyway, but I'm not sure what's happening with the planes, but I would not like to be on that one. And also I asked, can you give me some people that are discussing things? And I'm not sure that qualifies as a person. So I don't have an airport example here. I could get probably a far-stretched one, but yeah, it doesn't add value. So let's go to a real-life example. If there's people that have never used Kubernetes and don't know what limits and requests are and how they impact your application, if you have a template or a golden path to get started, that helps them and other new teams. If there's teams that ask you about specific CSI drivers because they have specific applications that need that, it also helps you think, how can I deliver that to other teams in an easy manner? And is that even something other people will use, or is it specific to this one? Then I take a small side step, because as a platform engineer, if you're working at organizations, you usually work within the context of the organization. But how do you keep up with all the new things, maybe AI or developer platforms or platform engineering in general? And how can you offer your platform in an easy manner and keep on developing that? So at DevTeam, a couple of colleagues of mine, we decided, you know what, developer portals. Sounds fun, let's actually try it. So we made an internal project, because it sounded so easy. You just put a developer platform in front of your platform and it's great, works. It does, if you don't customize anything, it's great and easy. So we did it with infrastructure as code, with Argo CD, deployed everything. And then, because we got to experiment with it, we could also talk with clients that said, I want this new shiny thing, and ask them questions about, but why? What problem do you actually want to solve? And are you sure this will solve it for you, or just create more work? Usually create more work. There was, however, one client who was already in the middle of implementing it in an organization where it also made sense. And they said, we're going to do this, but we are missing a specific functionality. Is there any way we can give feedback to the developer teams on how they are performing? So this is why I asked who was at the Ignite yesterday, because Yannis Orlovs talked about the DORA metrics, so I don't need to repeat them, right? Right. We made an OpenDoor App Plugin, so an open source plugin on Backstage where you can integrate your repos and you can see how well are you actually performing in a visual representation. And why is that platform engineering value for DevOps teams? Because the better the platform, the less time you need to spend on thinking about the platform, the better the metrics, because you can spend the time on your development or your deployment frequency, all these subjects. Not takeaways, but departures, because of the airport team, of course. So this is the closing of my talk. But I wanted to give 3 pointers to take away from this. And the first one is self-service is key. If we've been moving to give all autonomy to DevOps teams, we can't just take it all away and say you have to request things and it will take ages. It's too big of a jump. So self-service will help the developer experience and speed by giving feedback and giving the power back. The second one is offer easy benefits. This ties into the standardization, but if teams can build their own platforms fairly easy and don't need to talk to anyone, they probably will. So offer the easy benefit of the platform. Say actually, you know what, security governance, you don't want to think about it, give it to us. You can do your job. And then the third departure is the better the platform, the better the developer results. Thank you all for listening and for the chaotic